Hello, I welcome you all in this lecture related with the subject failure analysis and prevention. And we are talking about the failure analysis of castings. In this presentation, I will be taking up the two examples related with the failure of the cylinder head and piston. Initially, we will try to talk about the common causes of the failure of these two components, and then how does the issues related to the heat treatment, alloy composition, wear resistance and hardness can lead to the failure of these components. So, initially see the piston and the cylinder head, their position, role in IC engines, and the common causes of the aluminum piston and cylinder head failure, and the common aluminum silicon alloys which are used for this, like LM28 and LM13, the structure and properties of these alloys. Considering the symptoms and the composition and the properties of the aluminum alloys, and the preliminary examination of the failed components, suitable failure analysis procedure is established, then finding and observation and general strategies to avoid the failure. Okay, these are the different components related with this presentation. So, in IC engines, we know that these are the main components we can see in this diagram. Camshaft, which will be regulating or operating the valves for inlet and exhaust of the, for inlet of the fuel mixture and exhaust of the burnout gases. Okay, then there is a cylinder head at the top of the engine block, and then there is an engine block in which everything will be fitted in. Then inside the cylinder there is a piston. Okay, and the engine block will be cooled to maintain its temperature, and the power generated will be converted, reciprocating movement in the power generated results in the reciprocating movement, which is converted into the rotary movement with the help of the connecting rod and crankshaft, and there is a crankcase also. So, this case study is particularly related to the cylinder head, say, and the pistons. So, this is the piston part, and the cylinder head is bolted or fitted at the top of the engine block. So, the top and separate part joint in leak tightness manner with the top of the engine block. Okay. In the cylinder head, we will see the different components being mounted, like the walls, and the spark plug may be there as per the case. So, the cylinder head accommodates the intake and exhaust valves, spark plug, and the camshaft which is operating these valves. So, the cylinder head and the engine block can be of the same or of the different material. The problem here is, if they are of the different material, then thermal expansion and contraction behavior will be different on heating and cooling during the operation. Usually what happens, like sometimes we have the cast iron engine block and the aluminum cylinder head, and because of the difference in thermal expansion coefficients, say from the 10 to 12 for Ci and 18 to 22 for the aluminum, this large difference makes the differential results in the differential expansion and contraction, and which in turn promotes the thermal fatigue kind of the situation. Okay, and on the other hand, if you see the piston, if made of the piston which connects to the connecting rod with the help of suitable pin, and at the top we will see the piston rings, then the top surface of the piston and the lower section of the piston. So, accordingly these are the different terms and the names are given to the different parts of the piston. Okay, cylinder head failures which are common, the common ways by which cylinder head failures occur, like aluminum cylinder head failure can be caused by the number of factors, say the presence of defects in the casting, okay, porosity and cracks. So, the pores and elongated cracks, these easily grow because of the stress conditions being experienced, thermal fatigue being experienced by the cylinder head. Poor surface finish, sometimes the rough surfaces and the holes which are being drilled are not proper, and then these will be leading to the stress concentration, okay, and initiating the crack, and which will eventually propagate. The dendrite arm spacing means the cast quality is not good, leading to the coarse secondary dendrite arm structure, leading to the quality poor strength of the alloys. So, like the defective casting, improper machining leading to the very high roughness, poor surface finish, and the coarse dendritic arm spacing. All these will be indicating towards the poor quality of the casting or the poor machining conditions. As I have said, differential metals means the engine block of the cast iron and the cylinder head are of aluminum. Due to the heating and cooling cycles experienced by the cylinder head causes the thermal fatigue. So, thermal fatigue causes the very stressful conditions if the different metals are being used for making the engine block and the cylinder head, and that can promote the cracking. Thermal damage in form of distortion due to the overheating can occur in case of the coolant failure, and the thermal distortion caused by the large temperature changes leading to the coolant or oil leaks and the lack of power being generated by the engine. Similarly, the aging, the harsh weather conditions and poor maintenance can also cause the damage to the cylinder head. So, as far as this particular case is concerned, where we see the cylinder head got cracked. Okay. So, the cracked in vicinity of the hole which were there to accommodate and to for the bolting of the cylinder head with the engine block. So, this cracking was supposed to be investigated. So, initially based on the initial investigation, it was thought out to be like high brittleness, okay, low toughness and ductility, unfavorable operating conditions like the possibility of coolant improper working of the cooling system, poor phases in the cylinder head material or the stress concentration. So, if the drilling is not proper, improper drilling of the hole, okay, poor phases like the aluminum, silicon, iron rich intermetallic compounds which are hard and brittle, unfavorable composition means the composition in terms of the aluminum, silicon, copper, manganese and nickel which are expected to be there are either on the too higher side or on the lower side, or the poor toughness and ductility due to the improper heat treatment condition or no heat treatment condition. So, brittleness, very low ductility, these will be promoting the cracking under unfavorable conditions. Okay. So, on the other hand, if we see the piston and their failures, so the piston, the fuel is injected, and then in case of the petrol engines, the spark plug will ignite the system and then the gases will be burning and pushing the piston down. So, for the generation of the power. Okay. These pistons which are made of say aluminum and with the piston rings of the other materials which can be used. So, there are 4 parts of piston where most failure occur are the head of the piston, piston rings, skirt of the piston and piston liner. Okay. So, the piston head failure can occur in form of seizures primarily due to the overheating caused by the failure of lubricant, failure of the cooling system or issues with the assembling approach and the very tight clearance at the top. Okay. Impact that can be observed at the top surface due to the incorrect gap between the cylinder head and walls, wherein the walls are hitting the top surface of the piston, wall clearance is improper or wall timing is improper. So, that can lead to the damage to the piston head. Cracking like the lack of piston cooling or overloading can promote the cracking of the piston head. Okay. So, these are the some of the causes related with the piston head failure. Then piston ring, like wear of the piston ring which may be in form of axial and radial due to the improper piston assembly, wear of the piston rings and grooves or abrasive particles are coming in between the cylinder liner and the piston due to the impurities and abrasive particles with the lubricant. Okay. The piston skirts that can get damaged, the lower part of the piston that can get damaged due to the wear, 2 body or 3 body wear and distortion of the connecting rod and the cylinders, and the seizure due to the over tightening of the pin and the failure of the coolant and lubricant. And the lining piston liner can fail due to the cavitation and the carbon oil deposition. So, this is an important to understand like how the failures occur, like this is the cylinder wall and this is the piston and in between we have the film of the. So, this is the cylinder wall and this side we have piston which is moving up and down. In between we have the film of the lubricant in order to avoid the direct rubbing of the piston with the surface of the cylinder to minimize the wear. But the moment when the particles come in between, okay, abrasive particles come in between through the lubricant, then this causes the indentation both on the piston as well as on the cylinder liner, okay, and that will be promoting the wear of each of these parts. So, when the rubbing is there between the piston and cylinder directly due to the failure of lubricant, it leads to the two body wear, okay, when the two bodies are interacting directly. But when there is between the two bodies there is an abrasive particle, so there is a presence of one side piston, another side cylinder, a liner, and then the abrasive particle. So that leads to the development of situation of three body wear. So hard particle will tend to indent either of these two members with which it is interacting under the pressure or the load, and will be causing the scratching, okay, and that will be lead in the consistent operation in presence of the abrasive will be leading to the three body abrasive wear and removal of the material, loss of the dimensions of the piston and the liners, etc. Okay. So, this is how we can understand the two body and three body abrasive wear. Usually, if the abrasive particles are too much and they remain there for long due to any reason, then that will be increasing the rate of wear. So, wear rate, if we see as a function of the time, the wear volume, okay, in terms of say cube, that will be increasing gradually under the steady state condition. But in case if there is a failure of the lubricant, or the failure if the lubricant is not there, then the wear will be happening at a very accelerated rate. So, that will be leading to the metallic wear or the seizure kind of conditions later on. So, that will particularly be happening when there is a the failure of the lubricant. So, if we see, this is the piston where this the skirt of the piston has been subjected to the wear lines. So, the consistent and continuous loss of material in this manner will be leading to the loss of dimensions and shape, which in turn will be promoting the loss of the power being generated and eventually the failure of the or the fracture of the piston. So, what is important, what is causing the wear? So, material must be hard enough, okay, it should resist the wear, and that is achieved through the proper fine grain structure and proper morphology of these grain structures, proper composition of the LY, okay, and therefore, we will see that what are the main factors that can govern the failure of the piston due to the wear, like say low hardness, not proper heat treatment leading to the desired hardness and desired microstructure, reduced wear resistance, and abrasives are present in the lubricant. So, if we see, if the LY in the say if we simply conduct the adhesive wear test as a function of time, we will see that the wear volume, okay, in terms of the cube, that in as cast in heat treatment condition it will be showing the low wear rate, while at the high while in as cast condition it will be showing the high wear rate. So, what it is showing under the identical conditions, it can show the very different the wear behavior of the aluminum silicon LY if it is either not of a proper hardness, low in hardness, high in hardness, or the structure is very coarse needler. In as cast condition, wear resistance is poor, or too much of the abrasives, okay. And another important thing, wear resistance of these adhesive wear, particularly adhesive wear of the aluminum silicon alloys with the counter surface say cast iron or steel, it may range like say 10 to the power minus 5 to 10 to the power minus 6 when there is no lubrication, and when there is a lubrication 10 to the power minus 8 to 10 to the minus 10. And the most preferred situation will be when it is less than 10 to the power 10 gram per meter kind of the wear rate of the aluminum alloy during the operation in presence of the suitable lubrication. What happens when there is no lubrication, there is a direct contact between the cylinder and piston, And if that is the case, if the piston and the cylinder are interacting directly, then there will be too much metal to metal contact, leading to the accelerated adhesive wear. So, presence of the lubricant in between the cylinder and in between the uh, piston, what it will be doing? So, the presence of lubricant will be reducing the direct metal to metal contact, and facilitate reducing the friction and facilitating the smooth operation with the very less wear. Okay. Now, so for the investigation purpose, what we need is we have to check really how sound the casting is, or if there are any issues or not. So, for that there are certain things like we can do NDT, or we can do the macro or microscopy. So, NDT is tricky, especially in aluminum, because we cannot apply, aluminum being the non-magnetic material, we cannot apply the magnetic particle testing. So, it makes difficult to check the fine cracks and fine porosity using the DPT, and that may require the X-rays or the ultrasonic other NDT techniques. Like say in this case, the very fine gaseous the defects are present. So, this is important to see which kind of the NDT will be applied, so that it is really able to reveal the kind of defects which are there in the castings. So, now we will take up the case study related with the failure analysis of the three components which were produced by the aluminum casting process. We know that the aluminum is a very light metal and is preferred especially for the high strength to weight ratio applications. Say in automobile, this is very important. So, you will see that the piston and the cylinder head, these are the two common components in automobile which are made of the aluminum silicon alloy castings. There is one more example of the aluminum housing made of the again aluminum silicon alloy casting. A particular alloy grade is A356. So, the failures of these three components took place in the different ways, and so we will try to investigate how the failure of these three components took place and what can be done to avoid their recurrence. So, you know that the piston is an important component of the automobile, and when one of the pistons failed prematurely during the service, then failure analysis was conducted, and what was done as a part of the failure analysis, like visual inspection. So, visual inspection initially showed lot of wear marks and abrasive marks on the surface of the piston, and that resulted in loss of dimensions and shape. So, the loss of dimension and shape resulted in the improper performance and working of the engine. And In addition to the visual inspection, considering the degradation or improper functioning due to the wear, the mechanical properties, composition, microstructure and wear behavior was investigated. Okay. So, that some meaningful conclusions can be obtained why it was subjected to the rapid wear. So, the piston was made of alum 13 alloy, wherein the desired the hardness was in the range of the 105 to 124, but actually the piston which failed had the hardness of 90. Similarly, the tensile strength of the piston material should have been in the band of 208 to the 252, but it again had the lower strength. So, the piston which failed prematurely had the lower hardness and lower ultimate strength. Okay. And additionally, the compositional analysis was also performed to see how the actual piston, what was the actual piston composition and what was the composition as compared to the standard one. Okay. So, the piston showed like say around 12% of the silicon, 1.4% copper, 1.2% manganese, nickel, etc., as compared to the, and these were very much in the band of the required composition. So, the things were such that it was deficient in terms of the mechanical properties. So, what was the reason behind that? The wear behavior was also wear behavior of the piston material and the actual alloy what should have been there were compared, and the piston showed much higher wear rate as compared to the alloy, which was the expectation or as per the design requirement which it should have. So, the piston material primarily showed the eutectic alloy composition and with the full of the silicon needles. Okay. So, this alloy is in, this is a typical feature corresponding to the as cast alloy behavior, like say as cast alloy aluminum silicon alloy of eutectic composition shows this typical kind of the microstructure. When the desired one means the expected microstructure should have very fine spheroids, spherical and the refined eutectic silicon in the matrix of the aluminum, and which is obtained through the heat treatment only. So, the desired one should have this, which is obtained through the heat treatment, but actually the piston which failed had was in the as cast condition, as it was apparent from the microstructure. Okay. So, this was the another discrepancy or the weakness which was observed in terms of the condition in which the piston was being used. It should have been in the heat treated condition, not in the as cast condition. Okay. So, now if you will see the another case study is the failure analysis of the cylinder head. The failure analysis of the cylinder head was carried out using the following steps. Say the visual inspection was the first thing which is usually carried out to see where what is the failure area, what is the failure location, how whether there is a crack or wear marks or corrosion or anything else like that. So, the crack initiated from the high stress area formed due to the defective hole created by the drilling. Okay. And near the fracture surface pores were obtained. Okay. So, the near the crack initiation site the pores were observed, and so these were the two observations from the visual inspection. In addition to that, mechanical properties, composition and microstructure study and other IMC studies were carried out, if any, which are promoting the cracking of the cylinder head. So, say the cylinder head was made of LM28 alloy for which the desired hardness was 115 to 145 and the desired strength, ultimate strength 140 to 180 MPa, while the cylinder head showed much higher hardness and much higher tensile strength, which indicates that this is having the much higher hardness and strength. So, of course, it will be having the lower percentage elongation, that is ductility, and the lower toughness. So, this will be making the alloy more sensitive to the cracking in presence of the stress residues. So, the alloy composition was also checked for the presence of various elements like silicon, copper, magnesium, nickel and other elements. So, the standard alloy should have the alloying elements like this 17 to 20%, copper 1.3 to 1.8, magnesium 0.8 to 1.5 and nickel 0.8 to 1.5. Others allowed is 2% of the other elements. Cylinder had the silicon of the 18% and other elements were very much within the range, except the iron was too high in terms of the weight percentage. So, whenever in these aluminum silicon alloys, whenever the iron is present, it promotes the intermetallic compound in form of hard and brittle needles of the aluminum FeSi. So, these are the IMCs which are formed and in the form of needles, and that promotes the embrittlement, increased hardness, increased strength and increased nose sensitivity and cracking sensitivity. So, this was happening primarily due to the higher iron content, In addition to that, when the microstructure study was carried out, the cylinder was found to have the S cast structure with the alpha aluminum and the eutectic matrix, okay, with the primary silicon particles, okay, as desired or as it was expected, because it was the hyper eutectic aluminum silicon alloy. So, it is supposed to have the big primary silicon particles, but this is the condition in case of the as cast alloy. Well, it was desired that the alloy should have been in the heat treated condition. So, the desired structure was like eutectic silicon should be fine and spherical in form of spherical particles, apart from the little reduced size of the primary silicon particles. This is much more favorable in terms of the reduced cracking tendency and increased resistance to the crack nucleation and propagation. Okay. So, additionally, the microstructure study was also carried out to see how the higher percentage of the iron is contributing, and it showed the needles of the iron, aluminum, silicon, iron rich intermetallic compounds. So, these are known to be very hard and brittle. This is a typical Chinese manuscript kind of the IMC of the aluminum silicon iron, and which are known to promote the hardness, reduce the ductility, increase the cracking sensitivity. So, in order to take care of it is important that suitable iron corrector in form of manganese or chromium is added, so that negative effect of the iron in aluminum silicon castings can be reduced. Okay. There is another analysis, failure analysis of the aluminum silicon aluminum housing, which was made of A356 alloy. Failure analysis procedure followed was like, initially the observation showed that housing had a crack which initiated from one of the locations in the housing, and the procedure which was adopted for the failure analysis included chemical analysis, microstructure, visual examination and mechanical testing to establish the cause of failure. So, initially the composition analysis was carried out to see, since the casting was made of the A356 alloy, for which allowed silicon content iron, copper, manganese, chromium, nickel, zinc, titanium and balanced aluminum is in this range. So, what it suggested that the silicon is very much in the range, likewise iron and the copper and chromium and nickel, the zinc. So, predominantly the alloy is aluminum silicon kind of the thing. So, it was very much in the range, okay. And the study showed that there was a crack okay, near this in this housing, and what was the reason behind the cracking of this aluminum housing? The mechanical properties were investigated to see the transverse section of the housing showed the yield strength 170, 260, ultimate strength 265 and elongation 1.3, hardness 113 HP. Okay. Longitudinal section showed 185 and yield strength, ultimate strength 288 and elongation 145 and hardness 133. So, if we see a specified requirement of yield strength greater than 165, which was being satisfied, as ultimate strength greater than 234, which is also satisfied, but the elongation should have been little more, that resulted in the increased cracking tendency, and the hardness was little lower. Okay. So, when the study was carried out to see like what despite of reasonably good combination of the tensile strength and the hardness, the why it failed in very brittle manner. So, what has been observed, like it had a lot of discontinuities in form of the pores. These interdendritic pores were the main reasons behind the cracking tendency of the alloy. So, the failure analysis of thin section component made of this alloy failed in very brittle manner, primarily due to the porosity, which resulted in a compromised mechanical properties, especially the ductility, and porosity induced the crack initiation. So, as the summary, the piston failure analysis of the piston suggested lower hardness, lower wear resistance, lack of heat treatment. So, remedies are obtain desired microstructure through the heat treatment, increase the hardness for desired wear resistance, and use proper lubrication. And as far as the cylinder head investigation is concerned, the failure of the cylinder head occurred due to the gaseous defects, stress concentration near the hole, formation of the iron rich IMC formation, higher hardness, and lack of heat treatment. So, suggested remedy is do the proper drilling of hole in order to avoid the stress concentration, do the proper heat treatment, and ensure proper the melt treatment in order to reduce the porosity and avoid the IMC formation using the proper iron corrector. That's all from my side in this presentation. Thank you for your attention.